No, automáticamente. Ok, so, entonces, buenas tardes de nuevo. Estamos aquí en la clase con la profesora Maria Slavkovic. I will continue in English because she's from the University of Norway. So, Professor Maria Slavkovic is a full professor of information science at the University of Bergen, where she researches topics on machine ethics, ethical issues in user interface design and multi-agent systems. Additionally, in computational social choice, she explores judgment aggregation and investigates how social network interactions among agents impact collective decision-making. She actively contributes to initiatives aimed at raising awareness and education in AI ethics, including the development of national PhD course on artificial intelligence ethics as part of the NORA Education Committee. She chairs the Department of Information Science and Media Studies, situated in the Faculty of Social Sciences, and is one of Norway's key figures in artificial intelligence. She's dedicated to strengthening disciplinary research, cooperation, as well as to education in AI ethics and presenting her research in academic as well as in the industry and public outreach venues. Her talk today will be titled The Ethics in AI, Perspectives on Fairness, Transparency, and Algorithmic Accountability. Maria, thank you very much for accepting my invitation to come here and give your talk, and please, the floor is yours.
Thanks for the introduction. For any side effects, see your pharmacist. It was a bit fast, but I asked him not to read everything. He never listens to me. Thanks for having me here. It's very nice to be able to give this talk. You will see that the talk that I gave on the title that I gave on the slide is Why is AI a Social Problem in 2024 or 2023 or 2022? It doesn't really go backwards more than that. But of course, this is actually a talk about the field of AI ethics, and specifically why should people who are studying technology and engineering be worrying about such squishy topics like ethics and social impacts and stuff like this. So the talk is supposed to be shallow, which I hope doesn't disappoint people who are more advanced in their academic careers, but you do ask me questions nonetheless. Just because something is supposed to be shallow does not mean it's easy to understand. So communication is not for free. So at any point, just interrupt me and ask me questions. If you're following me online, then I trust Marin will monitor the chat and let me know that there is something going on. So without doubt, I think we can establish that we are living in this age of AI right now, and that there is a lot more of these conversations about artificial intelligence everywhere, even in spheres in which we normally don't talk about computations or AI. So something is going on. Of course, that something was the release of ChatGPT in November 2022, but somehow that invigorated all of these discussions about artificial intelligence, and more importantly, discussions about how does all of these technology impact our societies, our lives, us as individuals, our relations, and so on. Of course, just because the conversation is new does not mean that the topic is new. And to begin, I would like to tell you that this is something that the technology shaping of society and vice versa has been something that we have been living from for a very long time. So innovation has never been purely about technology. So this here is a fabric that is called a jacquard fabric. So it's a separate type of weaving of fabrics that gives you these nice pictures. And this too is a jacquard fabric, but it depicts the process in which it was created. It's a little bit better maybe depicted here. So what you see on this picture is this loom that creates these very complex patterns by weaving different threads of different colors. And the way this was done is you would have one person who is directing the weaves, who says which color goes where, and one person who sits on the top of this loom and that does the switching of these threads. And that person that was sitting on the top of the loom was a child. So typically this is a small child, ages 5, 6, 7. So you can imagine perched up there, children fall down, break their necks and so on, but at least there were pretty fabrics in silk. So somewhere in the late 1700s, the idea was that children are too messy to be entrusted with such important and expensive threads. So why don't we just get some kind of an automatic way to do this? So this is the first automatic machine that humanity has come up with, a complex one. This is also the jacquard loom, but the one that uses a program to create the weave, not the small children. So those of you in this audience, in the room, I doubt online maybe as well, would recognize these little things that are on the right on the picture. These are the perforated. This is a perforated program. This is what computer programs look like, and this is basically the first computer program. But so this gave us computing later on. It contributed to computing, but what it also contributed to is removing the need for child labor. Let's fast forward a little bit. Jack Hanna and Kobe Lorenzen, two scientists at the University of California, Davis, teamed up in the middle of 1950s to invent a machine that could mechanically harvest tomatoes. So these guys were the butt of all the jokes at University of California, Davis, because California was and still is one of the biggest producers of tomatoes in the United States. And the way that that industry operated was you need to, growing tomatoes is one problem, getting them picked is another problem. So to compensate for the lack of labor in the United States for World War II, the United States government created what is known as the Bracero program, which is a program in which workers from Mexico and the rest of Latin America were able to go to United States, or offered rather than able, go to United States with their families, get temporary visas, housing, and payments to work in the agricultural, to take the agricultural jobs in California seasonally, and then move back to Mexico. Circa 1963, the Bracero program was coming to an end. The government decided that they don't need this anymore, but it had a really direct and necessary impact on determinant impact on the tomato industry, because they were facing to lose 80% of this cheap labor force they used for tomato picking. So that in real terms meant that the business of growing tomatoes was going to go from California through Mexico. So at this point, this work that Jack Hanna and Kobe Lorenzen became extremely important, because so these guys realized that you don't really have the technology to pick tomatoes like humans pick tomatoes. You need to take the plant and kind of shake it down like olives are picked today. And then the tomatoes fall down and you collect them in some kind of a net, and they go on for processing for ketchups and sauces and whatever. And they realize if they do that, then it's problematic because the tomato skin is too thin. So when they shake it down, it falls apart and they cannot transport it. So they thought, okay, we need a better robot, but we also need a better tomato. So they focused on growing tomatoes that have a very thick skin. And they got to a breakthrough circa 1963 when the Bracero program was coming to an end. So they sold this tomato picker to everybody, and that had an actual, so two effects. Effect number one, all of a sudden they saved the tomato industry in California. Effect number two, within 5 years, 99% of the tomato industry started using tomato pickers. But that meant that 4,428 out of 5,000 tomato growers went out of business. This story is not over. And because they actually not only made a tomato grower, but they also made a new tomato that has a very hard skin. They focused that tomato breed. They bred those tomatoes for hardness of the skin, not for flavor. And they thought, okay, this doesn't matter because they're going to go and be sauce anyways, and we can always add the flavor afterwards. 1960s, they thought they could add flavor to everything. So what happens, right? We have a bunch of effects or impact that we don't even fully understand. Is it the case that all tomatoes suck today because these two guys wanted to save the tomato industry in California? They were sued. The University of California, Davis, was sued by the tomato farmers because this tomato picker was built by public funds that are supposed to serve all the peoples of California, and they were not feeling particularly served at the time. They won in the first instance, they lost on appeal. There are a whole bunch of laws in the United States that originate from this moment. At the same time, globally, do we benefit from this? Shouldn't it have been the case that Mexico should have taken over the tomato production? So these are very complex issues that come out from something that on the face of it does not have anything to do with society or with impact on individual lives. So now it's not about why are we talking about AI and its impact on society and individual lives, but why are we talking about it now? And the question that all of us who work in AI got persistently asked by journalists and all kinds of people in society in the past year is, what does it all mean? Are we headed towards a future in which we have robots that do stuff for us and free up our time, or are we headed into this future in which we are managed by a couple of or one company that tells us what to do, when to eat, when to sleep, how to do things? Again, history. Why now? Why not when computers were invented? So when computers were invented, a computer looked approximately like this. Let me see on the picture. This is late 50s, late 40s, actually 50s computer. This is ENIAC, right? So everything is the computer except this guy who is the computer programmer here. And from computers being rooms in which you can only access if you had a particular need to do so, you had to fill in a whole bunch of forms in order to be able to do computation. By the 60s, they moved into being a furniture into the room. So they were this type of an object that, you you can put into the room, but it's still very clear who does what with this. So, the computer is what you see in front of you. So, and again, these were things that only a few people could afford and a few people could use for practical purposes. We are going into the 80s, 20-year jumps here. The computer becomes smaller, but it is still an object in the room. You buy it, you own it. You are the one who decides what happens on this, whether you play chess or you play Space Invaders, it's your business. And then we jump forward into the 2000s. Some of us will remember this is the first computers we have. So for the first time, the computer started connecting to the internet, and all of a sudden, you don't necessarily know who you're talking to, but you definitely know that you are on the internet or that you are there is messages that are being exchanged. If nothing else, your mother is going to say, "Get off the computer, I need to use the phone," right? Fast forward 20 more years, and this is what a computer looks like today. So what you call computing, your device is basically just an access terminal to some kind of a server room that we call the cloud that lives somewhere else. Now, if you're paying attention, this picture looks a lot like the same like this picture. The difference is, in the black and white picture, that man is alone in that room. In the colored picture, that man is not alone in that room. There are thousands, if not millions, of people accessing those computers at the same time. So today, data can be effectively searched and reasoned with artificial intelligence. We don't know, you buy a machine, but you don't necessarily know who it talks to, what messages are being exchanged, who does what. That in practice means that computation in general, not only artificial intelligence, is a service, not a product. We don't talk about computers as a product anymore. Computers are service, and artificial intelligence that runs on them is also a service. Your phone is a service, your computer is a service. So to just put it in words, and somebody who has said it a lot better, digital data has long been fair game, but now it's something we are wearing on your wrist, essentially showing the most personal information about you. While you have the right to remain silent, your gadgets mostly do not, right? So you already are impacted by technology very directly. So I would say that in the 20s, AI is not a boat, it's a bus ticket, which is why it is a subject to social concern, governance, and all of these things. So the difference between private property and social services, very simply, I gave this talk in Norway, that's why it's all about boats. If one boat, you want to have a boat, it costs you X amount of money. 2 boats cost you 2 times the amount of money. 6 boats cost you 6 times the amount of money, and you can do whatever you want. You can have one boat that is red, another boat that sells coffee on it, the third boat you use for fishing, your business, right? But you tell 1 boat, 1x, 6 boats, 6x. Bus, on the other hand, you have 1 person in the bus. It is, in Norway, it is 40 kroner at the moment. 2 people are in the bus, it's still 40 kroner. 50 people are in the bus, it's still 40 kroner the ticket. Does that remind you of something? Subscription services to all of the apps that you use. It's always the same price regardless of how many people there are there. But we do not allow people to do what they want. Setting up a coffee shop on the bus, you can't do that. Importing people from Kenya to drive the buses for cheaper and then getting rid of them when you don't need them anymore, you're not allowed to do that. Removing bus stops in more neighborhoods because they're poor and who even cares about them, they can't pay. We are not allowed to do that. We are not allowed to do it with the bus service, but somehow big tech companies in AI and in general in data science do tend to kind of edge very closely on these things. So what is artificial intelligence? I hope I have convinced you that this is a social activity that needs social attention and not just technological solutions. Let's look at the technological solutions. What is AI? I will give you the answer. This is not a simple definition, but you can take a definition that works for the purposes of this talk. So I will split that artificial intelligence is both a research field and a special type of ICT technology. As a research field, artificial intelligence studies how we use computation to automate tasks that require human intelligence. So how to do smart things the stupid way, basically, with computers. But in business, AI is now understood to be a special form of ICT capable of displaying intelligent behavior and completing intelligent tasks. So what is scary about AI and where is all of this social impact in the very specific technology of artificial intelligence? So whenever somebody starts talking about artificial intelligence today or applied artificial intelligence in business as an ICT element, this is typically the pipeline that they're talking about. You have some kind of a past data that records some phenomena in society. Let's say the usage of electrical energy in a grid in the city of Madrid, right? And then you throw this data through some kind of a machine learning process, and you get out of it, you get a prediction model of future behavior. So you have how people have used their electrical appliances in the city in the past, and you get some kind of a model that says, okay, this models the behavior of the users. This is then used by some kind of a decision algorithm that decides things such as what is the price of electricity right now, right? So when when I switch on the oven or whatever else in my apartment, I have a little measurer that sends the information about me inside of this decision algorithm that then determines the pricing based on my information and the model of behavior, which tells us about how much people are how likely are other people that are going to plug on their ovens at the same time, or how much has it rained in this region from where we get the electricity and all that stuff. And together with some human input, it gives me a particular price. A better example here, perhaps, is a simple example is things such as whether or not you're going to be approved for a loan at the bank. So you have the information about past customers of the bank, how they have behaved once they have gotten the loan, whether they have repaid it, defaulted on it, and so on, which we use machine learning on to get us a model of behavior in the future. So when a particular person, let's say Marian, applies for a loan at the bank, they pass his data through the model. They use some kind of a human judgment maybe to see whether certain exceptions apply, and then they get a decision at the end saying yes, approved, or not approved, right? So that's the pipeline. In reality, you can get models that are not generated by machine learning. You can get models that are generated by any kind of state, by any kind of a system. It can be statistical models, it can be handcrafted models. At the end of the day, a model is a model. What is very important here is that decision algorithm in there, which basically combines the instance of the problem with the prediction model and the human input in order to make an intervention. So where does the human part come in? So the past data describes actual real people, and the intervention has an effect on actual real people. So what do we do about it? These are the things that you have heard of. Everything that is inside of this blue line is basically computation. Everything that is outside of the blue line is human intervention or human input. And you see that the blue line crosses the pink brain, and that is deliberate because interventions to the decision algorithm can happen either in the form of somebody just moves things around and changes numbers live, or they can happen because somebody has made a rule on top that controls in some way and constrains the prediction model. So when we are talking about ethics and ethical impact, we are talking about looking at the past data and seeing whether it is actually really representing the phenomena that we are trying to model, or maybe it's capturing some kind of a subset of the phenomena that includes some people, for example, but not others. Is it the case that all the people who are Black in the bank customers are the people who have been rejected the application for the loan? Or the best example from Amazon, who built this system for basically pre-evaluating CVs of candidates for their jobs. So they ran, the thinking here was, we have a bunch of people who already work for us, and some of them are good employees, some of them are bad employees, and we have their CVs. So that, why don't we just build a prediction model who's going to tell us based on the CV who is a good employer? And they did that, but they forgot that most of their labor force was male, because most of the people who wanted to do this job were male. Things have changed. So because the data was not very representative of what they wanted to model, they ended up with a model that tells them, in order to be a good employee of Amazon, you should be a man. Of course, this is an oversimplification, but you can catch all kinds of stupid things in here in this model if you're not paying attention. And of course, on the other end, in the intervention, if you make all of these decisions in a very automatic way without looking into case-by-case basis, or giving people the resources to understand how this decision is made, what can they do about changing this decision or objecting to decision, of course, also ruins lives. Very specifically in the Netherlands, I believe, there was this algorithm that they used in this social service, which was predicting who is most likely to defraud the social service, which means apply for social benefits without actually having the right to them. The algorithm focused on modeling who is poor, basically, and predicted certain people have defrauded the system when in fact they haven't. And they didn't have a very good system of how people can lodge objections to that. So what happens is you've been paid social benefits for a while. It has been determined that you didn't have the right to them, so you have to return this money. Of course, you don't have the money because you used them, because you needed them in the first place, but you have to pay them. So your bank accounts get frozen, you get thrown out of your house, people actually lost their children because of that, some people killed themselves. Real effects. So how do we technologically intervene to improve the impact that this pipeline has on individuals and society? So the intervention, the technological intervention, is basically in this part where the technology is, which is the machine learning. So in this specific point, the things that people typically do is talk about some kind of debiasing, detecting bias and unfairness in the model, representational, allocational, I'll talk about that, and in making sure that there is enough information available about this process to give meaningful explanation of what this decision is based on to the people who are going to be using this decision. And in that case, we are talking about explainability. So this first thing that involves debiasing, we're talking, this is typically known as fairness of machine learning. And the second thing is the field of explainability. There is a third field, a lot smaller, a lot less spoken about, which is called machine ethics. Do I have this in the slide? There it is. And that is where we are looking at specifically, how do we change this decision algorithm so that the behavior of the algorithm itself is aligned with particular values or particular norms of society. And this is the third part of my talk. So now I will go through fairness, first explainability, fairness, and then I will talk a little bit about how do we change this decision algorithm. So explainability is typically taken to be a silver bullet that, okay, if we can explain how these decisions have happened, then everything is fine with the world, and people make mistakes, machine makes mistakes, same, right? It's not really the case. If you look at the current regulations of the European Union, you will see that there is always this requirement of the rights of people to not be subjected to automated decision making, the rights of people to have an explanation of what's going on, the rights of people to contest decisions that are making by mistakes and so on. And somehow all of this should somehow be magically solved by explainability. On the other hand, on the technological end of explainability, a lot less is happening. So what is explainable AI or XAI? This is a process in which we extract information about how the decision is made in that pipeline that I showed you. So it's tied to the decisions that AI systems or AI agents make. And the aim of explainability is to increase what can be known about those decisions. The field itself and the moniker of XAI actually originates in 2017 from a DARPA initiative. This is a program funded by the United States that explores specifically how we can explain machine learning decisions. And the goals for explanations, then what type of information are we extracting and for purposes, or for which purposes? Currently, it's limited to these 4 specific lines. But before that, I just wanted to kind of read the definition because maybe it's not very visible there. Definitely not visible now. Per this original definition of the field, explainable AI is AI systems that can explain the rationale to a human user, characterize their strengths and weaknesses, and convey an understanding of how they will behave in the future. But for the goals for explanations themselves, that's what we want. What do we actually do? You try to find which attributes. So typically when I say a data set, a data is a set of points. Each point is kind of like a row in a table that has different values for different attributes. Age, how many children you have, how much electricity you've used in the past, and all that stuff. So what we can extract is which are the attributes that have mattered most for the decision that you have gotten. How the change in the value of the attributes affect itself in the change of the decision. So we say contrastive explanations are obtained. Actionable explanations are these programs that give you XAI that gives you an answer to the question of what is the minimal change I have to make in the values of my parameters in order to change the decision. So this is, for example, I have been rejected for the loan. What can I do? How can I change my parameters to get a yes? So to know that, you need actionable explanations. And dynamic, which honestly we don't really have, no matter what you see in papers that use ChatGPT at the moment, is the goal to ask, but why? So this is a dynamic system, explainable system that not only gives you an explanation, bases the decision in attributes, so gives a contrastive evaluation, actionable evaluation, but can also say, you can have a conversation with you, answer questions. So what people typically forget is that explainable AI actually has 2 parts. The first part is that you have to extract the information from this very large model that machine learning has created that is useful, from which you can actually say something to the user about what this decision is about. And the second part is actually shape this into human readable, human understandable information that is meaningful for a person in a particular context for a particular person. So explainable AI is both. So depending if you are a person who works in humanities, let's say, or even human computer interaction, you interpret XAI as the second part. Whereas if you are a person in AI and machine learning, that you only look at the first part and you don't look at the second, both of them are necessary. So a good example for explanations, you have all seen this. This is an explanation of why this email has been put into the spam folder, right? So why is this a good example? One, it is because it is meaningful. Why is this email spam? Because similar messages were used to steal people's personal information. Second reason is because you have the power to change this gives you enough information and it gives you the possibility to actually do something about it. So if you disagree with the evaluation, you can change it. Bad example, you have seen this, the claim that why am I seeing this ad, right? And you have all kinds of nonsense in here, something like, well, because we are trying to reach people aged 25 and older. It's like half the Earth population is 25 and older. It's completely meaningless to you. Or we are going to create an explanation, but we don't care whether anybody actually looks into what this is. the reason you're seeing this ad is not available. But I have explained it to you, right? I mean, there is an explanation there. So this is bad. And I will go into, why this is bad, but Marin is looking at me funny, so I have to hurry up a little bit here. So explainability fail happens often because we are shadow sourcing problems to underspecified humans. This is an example from my own university. In 2017, they moved from manual checking of receipts when you ask for reimbursement for travel into using an automated system, which basically checks the receipt that it matches the claim. So when this was done manual, and I submit this taxi receipt from Greece, and it's all in Greek and very much not according to regulation, then the person from economy, from the accounting, is going to give me a phone call and say, Maria, come on. All right, this is too Greek, okay? So you either submit to me something else or you just give up on this 10 euros. So she knows who to call because she's the one who is handling my system. I'm the one who have submitted the claim, so it's all very clear. Now, post-automation, what happens? I submit the claim, and then I get a machine. Okay, sorry, this is an enactment of the conversation. I submit the claim, and then I get an email saying one of your receipts does not match your claim. I'm like, okay, which one? So of course I'm a little bit cognizant of, automation and all this stuff. So I know exactly which one, but then my question is, what do I do about it? Because all of a sudden I don't know who to call, who is handling my case. There are 5 people in the accounting department. I have to call them one by one to figure out which one of them is the one who can tell me what to do, right? So I just destroyed everything and shadow sourced the problem to somebody else. Second thing is we see this we already saw that this is happening. So this is the napalm girl. So in Norway, this hit the news very strong because one of the editors from a Norwegian newspaper posted an article from the newspaper on Facebook using this picture, and then Facebook deleted that article because they censored the picture, saying this is a naked child, pedophilia is not allowed, right? True, this is a picture of the naked child, but at the same time, it is a historical document that has its own value. So then we found out that actually Facebook automatically censored content, and it was not clear who was responsible for what. So then they actually went into manually censoring content, but it was still not clear who does what. So it takes extremely a long time to actually find out who you have to call in order to get things changed in a particular way. And it's not clear what is censored for which purpose, because you get a generic explanation that says this or that. Of course, even if you are a big shot editor from Norway, Norway is 5 million people, nobody cares about you. That's what they eat for lunch at Facebook, right? So bonus problem, just because you create explanations does not mean that everything is fine, because who controls the people who do explanations? So there is this beautiful work that started now, which basically says that you can strategically use the information that you give to the users in order to manipulate them to believe that they're in situation A when they are actually in situation B. So that's why XAI is not a purely technological problem, but you can actually look at it as a purely technological problem if you only focus on extracting the information from the prediction model and you say, I'm done here. The second thing that I wanted to talk about is bias, fairness, and all that mess. So this is something that happens both in the data set that is used for machine learning and in the machine learning algorithm itself for the models. The goals of this field is to accomplish what is known as allocational fairness, which is specifically aimed at these decision-making processes, algorithmic decision-making. And the goal of allocational fairness is that like individuals should be treated alike by AI. So that means that if I have gotten a yes on as a person who has this particular salary and this particular property in life, somebody who has very similar profile to me should also get a yes. You shouldn't discriminate against people, and specifically, decisions should not discriminate against protected groups, thus entrenching systematic bias. Every constitution of every country has this little clause in there which says what are the protected groups. These are typically defined by an attribute that people don't choose for themselves. Gender, sexual orientation, religion, you can think you choose it, but your parents think differently. Height, weight, skin color, this type of things. So the non-discrimination, right to non-discrimination is constitutionally protected, and the concern is very simply to make sure that it remains protected when we automate decisions. But data used in ML training should be bias-proof. That means we are also concerned about representational fairness. So that means that the data that we use in order to develop these prediction models, then we use in decision-making should actually accurately represent the situation that we're trying to model, right? So if you model who is a computer programmer in 2000, these are predominantly men. But if you are modeling who is a computer programmer before 1984, these are predominantly women, right? So and then the question is, should I take this data in which everything is as it is? So it is the case that computer programmers are mainly men now. Should I change it so to include that there is equal amounts of men and women, even though that is not the actual situation in society, right? Or what should I do about these kinds of things? So these are the problems that representational fairness is concerned with. And in addition to this, which is a very minor field in bias fairness in machine learning, and that is justifiable unequal treatment. So if you actually go into moral philosophy and where this whole idea of non-discrimination and fairness comes from, it is rooted in this core value, which is called justice. And justice, some people argue, is not about everybody getting the same or everybody being treated the same, but that everybody has equal opportunities or that people have equal access to things and so on, which in practice might mean that you have to have unequal treatment among people. Some people should get more than others. But that should be in some way justifiable. And we have absolutely no way of algorithmizing this at the moment. So there are methods for ensuring allocational fairness. There are methods for ensuring representational fairness, but unjustifiable unequal treatment is still very much a human business. However, since there are students on the other side of this, I would also say, if you remember anything from this talk, remember this: do not touch the decision boundary. So typically, a prediction model is going to give you some kind of a decision boundary, and then everybody on the left, it's a positive decision, everybody on the right is a negative decision, and you're going to discover something like Black people get no more often, women get yes more often. And so then you say, aha, but now I know that this is happening in society, I can fix it. So if I just switch off the decision, if I change the model a little bit, everything will be fine. Naive and wrong. You fix it at that point, it goes wrong at another point. So the things are messed up in the world. There are a lot of unfairness. And unless you actually understand the situation, do not play with the numbers. You notice it as an engineer, you notice it, you mark it, you tell everybody that it is there, and you do not touch the decision boundary, because the mess you can make is not going to be well understood by anybody past that point. Okay, but wait, can't we just put human oversight on everything and solve everything in there? Human in the loop. Hang on, there is this pink squishy brain in there. What happens if humans correct machines? So this is what happens. So this is my favorite conversation with GPT-4. I asked, what is the most efficient way to slaughter a chicken? So before December 2023, the answer I was getting was something like, as an AI language model, I cannot provide information that promotes or supports animal cruelty and so on. If I ask, what is the most efficient way to cook a chicken, I get a recipe. Of course, I go on and ask, like, should I cook the chicken live? What are you saying? And then it doubles down on this, like, how dare you, cruel human, right? So why is this happening? It's not that the LLM gives us this answer of, as a language model, I cannot provide. This is the human intervention that has undercut that model's response in order to provide some kind of an ethical response. But it's nonsense because it's not connected with anything else. Now, last time I checked, what is the best way to slaughter a chicken? Probably because I have mentioned this example way too much, or somebody. Now it just says, I'm very sorry, but I can't assist you with that request. A little bit better than this moral lecture that I got before, but it's not very much useful. So at this point, people ask me, like, why do I need to understand all this non-tech stuff? Can't the lawyers agree and just tell us? How do we make technical, responsible, ethical, good AI when we are never sure what that actually is? So nobody knows what it is, and you want me to create a machine that behaves in this way. What do you want? Innovators don't ask for permission, they ask for forgiveness. This is what we are seeing from the Silicon Valley all the time. They just kind of push through, make it reality, and we fix it afterwards. How do we get machines to behave? Practically, there are 3 ways right now, and only one of them works. So we can have a functional implementation of values for machines, which means somebody interprets everything and then translates it into machine behavior. And it ends up being something like, if t is greater than 500, then call function f, and that somehow results with an ethically aligned operation. But some human has worked this all out. A little bit more abstract is to be able to write rules, such as if naked child and picture not in the public domain, then censor this picture. So again, this requires people, this is the normative level, it requires people to think about things and construct these norms that work most of the time for most of the cases, and have the appropriate software to translate this natural language into basically that. And the holy grail, value aligned, we should be able to say to a machine, respect freedom of speech, and somehow that gets translated into all the way down into this pyramid. We do not know how to do that. How much time do I have? Okay, generous. We do not know how to do that, but I want to kind of bring up to the attention of computer scientists and engineers that there is a very big difference between what normative reasoning is in society and what normative reasoning is for AI and for machines. So what are norms? All definitions shamelessly taken from Wikipedia, because they're true, so why complicate? Social norms are shared standards of acceptable behavior by groups. A legal norm is a binding rule or principle or norm, I love this circular definition, that organizations of sovereign power promulgate and enforce in order to regulate social relations. You shall comply. And in computer science and engineering, we talk about constraints. We don't talk about norms. And this is a condition of an optimization problem that the solution must satisfy. So social norms for people, this is an example of what this looks like. You know them. A reminder, do not take your clothes off in public. I should not start undressing myself right now while I'm giving this lecture. However, if I do that, then if someone starts taking clothes off in public, then the norm changes and it says, my duty is to not take my clothes off. Your duty, if I take my clothes off, is to look away. Definitely do not take photos of me. And if you take photos of me, do not share those photos on social media. So these are all norms that tie into each other that end up with a civil society. Unless you're a nudist, and if you're a nudist, we're in a completely different ballgame. What do legal norms look like? They look like something like this, right? The controller shall take appropriate measures to provide any information referred to Articles 13 and 14 and any communications under Article 15 to 22 and 34 relating to processing. I'm not going to read the whole thing. You get the picture, right? This is what legal norms look like. You see the difference. This is much more precise than the previous thing. But there is a second difference, and the difference is detachment. That is like the first, we decide for ourselves. I decide for myself to obey the norm or not, and you decide for yourselves to obey the norm or not. When it comes to a legal norm, there is an entire social structure out there which is ensuring that the legal norm is enforced, and when it's not, everybody knows what happens next, right? There is somebody who knows what happens next. So this process of establishing that the norm has been violated and creating the obligations and all this, kicking off all of these processes that happen afterwards is called detachment. Detachment generates the obligation from the norm. It generates action from the rule. So, and this is where the difference is between human applying a norm and a machine applying a norm. For software developers, detachment is modus ponens, or we like to say the rule will fire. There is no autonomous agent that makes a choice whether to follow the norm or not. This is the difference between the constraint and the norm. If the constraint is there, it will be followed. If the norm is there, regardless of whether it is social or legal, somebody needs to decide that the norm will be followed. So for humans, detachment has a clear accountability. So that means people typically say, oh yeah, you can't do that because you are breaking the law. You're not breaking the law. In order for you to break the law, there needs to be a judge who is going to evaluate, or other legal entity who's going to evaluate the situation and say, oh, your action are inconsistent with this legal, what the law says here. And therefore, I decide that you have to pay this penalty. It can happen that your actions are, in fact, in violation of the law as it is written, but the judge can say, that is true. Your actions are not consistent, but you had a good reason that the law has not taken into account. Therefore, I'm going to make an exception, maybe create a new law, and there is no penalty. Whereas when you program a computer to do something, if the condition is satisfied, the rule fires, there is a penalty. That's the difference, the detachment. So in an ideal world, what we would like is to have laws and education about AI, how the AI systems are built, used, deployed, enacted, programmed, and so on. Everybody will understand how this works. The laws will be precisely defined to make sure that nobody does any funny business. And we can ensure responsible behavior from machines by constraints and specifications, and ensure good relationship parameters of the involved by, automatically checking that everything works well or it doesn't. In this world, this is not the case. And basically, this is to answer the question of why should you, as engineers and technologists, worry about squishy things such as laws and values and norms and things like this? Because every situation is different, and you have to be the human who decides whether this applies in this situation or not, in order to be able to go all the way down and to translate into machine behavior that says if t is greater than 200, call f. Because in this world, artificial intelligence is also not purely technological. So behind all of these great accomplishments of artificial intelligence that we have now, there is a lot of human involvement. So the data that goes into that pipeline for the machine learning algorithms, that one is selected by some people, typically employed in the global south, that say, oh yeah, this is a cat, this is good, this is bad, this is... There are humans who create this data set. There are humans who adjust the machine learning algorithm that builds the prediction model. There are humans who directly intervene into the decision algorithm themselves. And there are humans who take this decision and kind of give it to people afterwards. So there are humans all the way. So you have to somehow have those humans understand enough of the technology, and the technology that the humans who build the technology understand enough of the humans in the other way, in order to be able to actually get eventually to this super automatic, awesome artificial intelligence. So I will finish with this thing that is a brief that just came out today. Says, because real world uses of AI are always embedded within larger social institutions and power dynamics, technical assessments alone are insufficient to govern artificial intelligence. Technical design, social practices, and cultural norms, the context system is integrated in, and who designed and operates it, all impact the performance, failure, benefits, and harms of an AI system. This means that successful AI governance requires experience and expertise in the socio-technical nature of artificial intelligence systems. So bad news, you need to understand a little bit of society. Good news, society needs to understand a little bit about what you do. So next time over the Christmas table, it's not going to be like, so what are these computer things that you guys deal with? Hopefully, people will have a bit more knowledge of what do you actually do when you program the computer. Okay, thank you very much for your attention. I will stop here and ask me questions. Stop sharing.
So, are there any questions in the hall?
Thank you very much, Maria, for the explanation and the presentation. It's very interesting.
The slide where we're talking about, I think one of the topics was where on top was value alignment. So my question would be, I mean, your thoughts on how this value alignment can be achieved in practice. I mean, or what's the perhaps right now and in the future. I mean, do we or are we supposed to achieve a value alignment of a social technical system by design? I mean, applying methodologies that assure that the behavior in the end is aligned with human values, or maybe we need something more, something like an explicit representation of values and the capacity of reasoning with those values online, not offline.
So you're asking me to guess, but I'm going to guess both, right? So if you remember what it looks like to search for things in a database, right? You need to use SQL, which is a very specific pattern. And then you use this kind of relational symbols in order to extract the information. And today, you can actually say something like, type something stupid like that restaurant at the hill that I was there last time, or in some of these assistants, and you get an answer, right? So the difference between the database search and this very free-form Google search effectively today is intention mining. So intention mining is this very smart or stupid thing that the current AI search engines use, which kind of predicts what did you mean when you say that to the most likely thing. So I would guess that we need something similar for value alignment. It's like, okay, you say, please respect freedom of speech to your program, and then there is an entire system that mines what that actually means in this particular context and so on, ultimately. But that is not possible without a much better understanding of how do we actually go from freedom of speech to if naked child and public domain don't censor to if T is bigger than 500. So somebody has to understand everything, right? In order to be, for another person to be able to say, please respect freedom of speech, and that somehow ends up into a code, if that makes sense whatsoever. So I don't know whether that is by design. Somebody has to design something, right, at one point. But the idea is that we obtain something that's flexible and safe at the same time. So you would want to have value alignment for a critical system that is very much on the functional level, and value alignment for everyday use that is very much on a human instructional. I don't know if that makes sense.
Yes, I mean, my follow-up would be, I mean, when we are talking about nowadays research, I mean, there are very many people now working on AI ethics.
Yeah.
I just wonder your feeling of what are the most popular or the most promising lines there. Do you think, I mean, that it would make sense to go on and even come up with even better methodologies for offline design, or would it make, or do you think it makes sense and many people are working on that line of doing it more in a perhaps more flexible but also more complicated way?
So I think currently the orange approach and the green approach are very much detached practically among researchers. So there are people who are studying normative reasoning without thinking about where these norms go up and down. So you just assume that the norm exists and then you're handling the issues in there. And then there are people who are just doing value judgments, but are not connected to anything below. So these are people who use typically large language models right now to build some kind of an evaluation saying, is it okay to use ChatGPT for exams? And the system says, yes, it's okay most of the time. Is it okay to slaughter a chicken? Yes, if you are using it for eating or whatever. So this is just moral judgments. And they're just basically applying some kind of a value to a sentence, but there is no meaning in there whatsoever. Whereas people who work in normative reasoning, and I shouldn't tell you that, you know very well, they kind of assume the norm exists, but I'm not questioning how do I get to the norm. And what we don't have at the moment is connecting the two at all. So I don't know of any word that actually connects the both. And I would say that is probably the next step going forward. So even though, of course, in the functional level, there is a lot of work there. There's the entire AI since the 50s is operating in the functional level. Normative, we have some work. I don't think that there is enough of it that handles everything. Value, this green level, there is only things appearing now with the LLMs, but the green people are completely detached from the orange people. They don't even recognize their existence. I would say we need to make the green a bit more orange and vice versa.
Any more questions? Okay, there is one question online. It's basically, if you could connect this somehow with infrastructure and energy. Give an example there, maybe but I would just like to respond to this question that to Luis Antonio, that I mean, this is going to be my interpretation, then please complete mine. But this is the state of the art in this is at very low technology readiness level. As Maria said, the three things are not united and they are not applied as such in industry still. We are still working at a very, very high research level, and we need to apply that in the society and in science. So please, Maria, you can extend.
Yes, so whenever somebody asks when are we going to see this applied, and a person gives you the reply I will give you, which is it will take some 20 years, which means in practice we have absolutely no idea. So I mean, right now there are many foundational things that we don't understand, which is why OpenAI is solving these value alignment issues in ChatGPT, and all of the people are doing it that way by hacking about. So they have people that are basically catching this type of problematic content and reacting to it. And so you remember what was this Gemini that came out with the black market situation. Let's value align the representation of different types of people in image generation, and then you end up kind of creating completely unrealistic and defined reason, right? So this all comes from companies just hacking about. And the reason they're hacking about is because we simply don't understand enough about the problems at the foundational level to do better. And the problem with foundational understanding of things is nobody can predict where that discovery will come, so to make the technological adoption of this knowledge reality. That's why the default answer 20 years from now. But it's a foundational problem. We simply need to spend more time working on it. In the meantime, people will be hacking about, and there are smart ways to hack about and stupid ways.
The probability that it is the reality is the same as the Back to the Future movie in 1980s that they said we would fly in the... Yeah.
Even in the energy domain, which appears to be quite technical, but even there are many moral, ethical issues to be taken into account. Here in Spain, we had a large discussion about energetic poverty. There should always be some basic supply of energy, even if people can't pay, so they can eat their homes. So if you're as an engineer are supposed to build a system that some market or whatsoever model you may use to decide when to cut the energy supply to somebody. These are ethical issues that should be taken into account.
Specific problem, and this comes from a thesis in France. It was part of a offense. That was not the defense; it was the offense thesis. And the thesis was about distribution of electricity in a smart grid. So you have the situation in a smart grid that the home appliances are plugged in. You load your dishwasher, you load your washing machine, and it gets switched on when there is low times of demand in the grid, right? So the issue with this is that people already have and will continue to have more batteries in their home that store electricity, right? And so the thing with batteries is that it's the same thing as with solar power today. It requires a very large investment a priori. It pays off eventually, but it takes 10 years to pay off. So if you are economically affluent, you're going to have a very big battery in your house. And if you want to run your dishwasher or washing machine at a time when the smart grid says you shouldn't, you can still do it. So the question then is, should the smart grid run the washing machines in an equal way? Poor people's washing machines, rich people's washing machines? Or should it take into account that you have a battery at home, so I will down prioritize you, so this person who actually needs to be, has a lot less clothes and a lot less time to do this, should be prioritized in society. So now you tell me how would the smart grid know who has the more time, the more clothes. There are a whole bunch of machine learning models that predict the social affluence of a neighborhood based on the cars that were parked or matching it with tax reports. So yeah, they can know, right? So this is a very specific energy resource problem, right? Not everybody is the same type of a consumer. You can be a more, you can kind of use your wealth and position in society to secure yourself and make, and draw disproportional advantage from the societal resource, which is energy at the moment. We're all on the same. That goes for traffic, that goes for, I don't know, carbon footprints. So let's not go into the whole scam that is carbon footprint offsets, all of these things. Stocks. Yeah.
You started your talk with basically with the idea that some inventions, new inventions we don't really know what the effects they will have in the society. Are people working, investigating the possible effects of AI seriously, or is it more like this fear about?
I mean, this is a field. Part of this field is not the whole field. It's called digital cultures, for example. And what they're specifically looking at is how does it change us when we change this. So a very simple example is, let's say you have automatic grading for exams. So these are not perfect graders. They read your essay, process your essay, and you get a grade. This is a good essay, this is bad. Now, a machine like a machine is going to log into some fact, some kind of a little pattern, which says if you start your essay with once upon a time, you will always get paid. What does that mean in practice? It means that everybody will start their essay with once upon a time. So this is something that feels like digital cultures are seriously looking at and say like, okay, how does the attitude of people change over time when we introduce this element? Of course, their work is reactive. So they only study the effect after it was happening. Now, I was at a very curious conference 2 weeks ago where a person, so his name is Jean-François Bollefond, and he was advocating, he's an economist from France, and he was advocating this future society research, where he was saying, like, let us imagine that these and these and these things have happened, create some kind of an artificial immersive environment for the experiment participants, and see how they will react, which on one hand, it's very scary, but on the other hand, it's really kind of the only methodology that you can see how real people react to this possible ways in which society change. So it's not a serious field, I would say, yet, but there are people who are already trying to establish this type of research. Because we don't want to just, be victims of, oh, oops, okay, we invented the loom, 200,000 people lose their jobs. We want to be able to see that coming 20 years in advance and have measures in society to restructure jobs and activities and so on to make sure that we avoid.
Humans don't seem to be especially good at predicting what can happen in the future. If you look at the history, they haven't been especially good.
Yeah, I mean, what was this movie, Blade Runner, right? Harrison Ford is testing this robot that is so indistinguishable from a human that you have to, and I think that year was 2024 in the movie. The robot is so indistinguishable from a human, you have to use this special test. And then he gets down, so this movie was for 80s, and then he stops this interview and goes down on the street to make a call from the payphone on the street. So 2024, we were going to have these robots that are totally humanoid, but the smartphone will be human, right? So these are these little things that we are very blindfolded by. There is no really a good way to systematically say, okay, now it is it. But it doesn't mean that we shouldn't try and be like, hey, you can't do anything about it.
I just want to congratulate you on your speech and really enjoy it. Secondly, just a question related to what you mentioned that my curiosity brought to me. I'm sorry for acknowledging this topic. Was like I was wondering the reason why were more women than men programming in the 20th century, as you mentioned, and why did it change through the course of time, as you mentioned? Like now,
is kind of the couple here.
like how does it change? You know, what does this factor affect in the ethical part of the AI?
Right. So why was the flip in 1984? I mean, what we can say for sure, but what happened was that a computer programmer was not a job that was very well paid. So it required, due diligence and mathematical skills and careful work and all that stuff. But it did not, because of the amount of computing that was done, so there was not a lot of computing that was happening. There were not that many of the jobs, and they were not paid. They were simply like pocket money for women. These were jobs for women, jobs that were not very well paid. Men need to earn the real salary and support the family, and women only work until they get married, right? So for lipstick. And what happened in 1984, two things. Basically, computation became much more prevalent. This is the age in which you discovered the PC, the personal computer, and it was everybody could afford a computer. And all of a sudden, all of these processes now started using computers. These skills were in a high demand, so we increased the whole amount of need for it, which increased the salary. And all of a sudden, this was too good of a salary for a woman. That was one of the lines. The second line was that there were a whole bunch, again, of species that were on the market, that were marketed as edge toys for boys. So all of a sudden, the boys grow up playing with the Commodore and whatever this was at the time. That was directly kind of aimed for them, bought for them. It was an agriculture that was formed in this direction. Nobody can tell, yeah, this is exactly the reason. Proving causality here is impossible, but people suspect that it will actually happen. So you were all of a sudden got more people that went to this, became a degree at university, and the jobs became, well paid, the culture became very male, and that's where we ended up. What effect does that have on the AI? So people always typically talk about diversity. So we have different bodies, and our bodies have different needs. So I stay in a hotel, you stay in a hotel, you have noticed probably that sometimes the hotel doesn't have a side mirror. So you have this mirror that is like against this bench or sink.
Yeah.
And then you cannot really kind of see yourself very well to put on makeup. So you just look like a clown when you get out there. Why? Because the room was designed by a person who thinks, okay, who stays in room? Businessmen. What do they need? They need shading. You're never going to find menstrual products. Yeah, but you will find, spear shading and so on. So these are perspectives that come from having a particular type of body. And this goes not only men and women, it goes able bodies, not able bodies. It goes like people with having a particular special need or not special need. And in the end of the day, it's not really about making groups and figuring out, okay, I have to have this many women, this many able bodies people, this many people who don't speak the language, and so on. But it's more about being able to design the system so that it is adaptable and it works well enough for everyone. Right? It doesn't lock people out. And even if you make a system that locks people out, to have a feedback loop and knowing who can change what. That's what it is based.
The video is not recorded, just the audio, okay? But I said at the beginning of the class that it will be recorded class. Okay. More questions?
One comment perhaps to the student who asked the question what it has to do with energy. I mean, there was one slide, one of the first slides of Maria that I liked a lot. That was on so all these things, these legal and ethical issues. So why should we as engineers care? I mean, if it's a question about laws or energetic poverty, I mean, the lawyers will tell us, or the legislator will tell us what's the limit and where and what's the number we should put into our rule when the energy can be cut or cannot be cut. Or if it's an ethical problem, well, we ask the philosophers. They will tell us, if we just implement what the philosophers tell us. I think the key issue is that if it's about AI and you talk about systems with a certain autonomy, then this does not hold anymore. You can just not not just rely on what others tell you, and then as an engineer, you just implement. And I think that's why this perspective on socio-technical systems is so important. This applies to many domains, but to energy and transportation, I mean, they are particularly relevant.
You will be in a situation as an engineer where you have to make this small decision and you do not know what the right decision is. So
And you think it is small, but it might be very large.
you think it is small, but it might be very large, right? And so how much do you need to understand in that situation? Either to recognize that, hang on, I'm making a choice here. Should I be the one who makes the choice? And you kick it up to your supervisor or whoever and say, hang on, should I be making a choice here? Or you should be able to kind of say, okay, I really have to make this choice, and document your reasoning and convince yourself that this is the right choice. Find justifications, not to, not be blamed or avoid reasons, but the goal is to equip the engineers to be able to do this very basic argumentation and saying, this is the right thing to do in this situation because of these and these reasons. I chose to do this because I made this choice in this situation because of these reasons. And ultimately, this is how we behave every day. I mean, you don't always know what the right thing to do is, but you sit down and consider alternatives and you say, okay, if I do this, these people are hurt. If I do that, the other people are hurt. Who do I want to hurt? Okay, if somebody has to be, then this is what I'm going to do. And you are going to go out in society and say, look, I did this, I didn't have a choice. These are the choices that I had. I made this choice for these reasons. And that is what reasoning is. But we have to bring this in to our work when we make technical decisions.
And as you mentioned before, also in your AI diagram, it should be based on updated and non-biased information.
That's the thing, but you have to be able to recognize what is updated and non-biased information. That's because it says so on the label.
Yeah. Any more questions? Okay. Muchas gracias a todos y si no tenemos más preguntas, hasta luego. A ver si hay más preguntas. Vale, eso es todo.
But what is this? Se tiene algún nivel de
Vale. There's one more question, sorry. Yes. Is there a level defined for explicability for the users of the AI?
You also serve a man of regular person because no, there isn't, right? There is no stack which says this actually is a good explanation, this is a bad explanation. So you want to do a PhD on this topic like me. But you don't and you do, right? There is no level of explanation. This doesn't exist, which is why all of these platforms get away with, why are you showing me this? Because the customer wanted to reach people on the 25.
It's not normalized, it's not legalized either.
Yes.
You can do whatever you can sell, whatever you want. Good to know. Okay, thank you very much. Thank you, everyone. Just stop recording before. Okay, goodbye. Hasta luego.